Unit 11, Part 3. So now I'm doing Section 2 of Klenk's Unit 11 of the book on scope of a quantifier, free and bound variables, and the scope of the quantifier. So the scope of a quantifier, so remember how we determined what the scope of a negation was in sentential logic, right? So there's a difference between, right, this formula and, right, the scope of the negation tells you, answering the question, what is the scope of the negation, is answering the question, what is it, what is the formula that the negation is negating, right? And you've got to answer that correctly, you've got to be able to determine that to correctly identify the form of the formula, right, of the structure of the formula. Right, so these are very different formulas, right? What is this? This is a disjunction. The major operator is a disjunction. Why? Because the scope of this negation is just A, right? We determine the scope of the negation by putting a hand over it and saying, when we get to the first complete formula, that is what it is that is being negated. And here, A is a complete formula. Compare that to this one, right? So that means that in the order of construction of this formula, we built not A, and then in the next and final step of the construction, we disjoined not A and B. Made a disjunction of where one of the disjuncts is not A, the other disjunct is B. So this is a disjunction. This one determined the scope of this negation. Okay, once again, it's the first complete formula that I arrive at when I move my hand to the right. I have an open bracket, which means I don't have a complete legal formula until I close that bracket. If I, as I go across, if I come across several open brackets, I have to close them all before I get to a complete legal formula. But here I've got one open bracket, A, and bracket A is not a complete legal formula, so I keep going. Or B, close brackets, right? And at this closed bracket I have a complete legal formula, so the negation, the scope of the negation is bracket A or B. Scope of this negation is A. Scope of this negation is bracket A or B, right? So this has a different order of construction than this one, right? This is, we made a disjunction. We disjoined A and B, and then in the final step of the construction of this formula, we negated all that, right? So what is this? It's a disjunction. What is this? It's a negation. Okay, that's the reminding you of what scope of negation is. Now we're determining the scope of a quantifier. And again, it is, as Klenk says, end of bottom of 217, is the first complete formula following the quantifier. And she says there, I want to specify, say something about, comment on this a bit. We are treating a propositional function like AX as a complete formula. So to quote her here, bottom of 217, here it is essential to note that simple propositional functions, such as fx or gx, are the smallest complete formulas in quantifier logic, and so serve as the building blocks for quantifier formulas, which means in determining the scope of the negation, right here, doing the second one first, right, moving to the right, ax, boom, that's the end. This is a complete formula, which means that is the scope of my quantifier, which means this quantifier is bound by this, this variable x is bound by this quantifier, so what that means, but any other variables that turn up are not, okay? Whatever follows here, none of this stuff, if there's any x's over here, none of them is bound by this quantifier. The scope of the ex is this, so this is going to be what? This is a conjunction where the left conjunct is an existential statement. Okay, but I want to say something about what she means by first, by saying that fx or gx, simple propositional functions are complete formulas. They are complete formulas, but remember they are not sentences. Okay, those two things are compatible. It's a complete formula. It's something which can be of itself bound by a variable, right? But AX is not a sentence. It is not not something itself capable of being true or false, right? It's something which is capable of being combined. combined with a quantifier, and now this whole thing is true or false, is a formula. But you certainly, even though this is a complete formula for the purposes of determining the scope of a quantifier, you never want to have on a proof anything like AX, right? Either of itself or as a subformula of some truth functional combination, right? So you don't want to have an AX or AY or AZ, and you don't want to have say a conditional where this is either antecedent or consequent. Because you have a conditional where this is antecedent or consequent, that's not true or false. So it's not the case that both sides of the conditional are true or false, so you don't have a formula that is determined as to being true or false. Okay. So the scope of this quantifier, this existential quantifier, is just AX. All right, so this, as I said, in the order of construction of this one, this is a conjunction, right? What is this? Remember what I stressed in Unit 10, and we'll stress again, especially around Unit 14. The form of a statement is either a quantifier statement or a conjunction or a disjunction, or right. So, if a formula is an existential statement or a universal statement, then it is not a conjunction or a disjunction or a conditional. And if it is a conjunction, then it is not a universal statement. So this is not a universal statement. This will be very crucial for when we get to the proofs, as you'll hear in Unit 14 and then Unit 15, introducing the proofs. Because this formula, since it is not an existential statement, you are not allowed to use the instantiation rules. You cannot instantiate from conjunctions, right? This means the rules governing the use of quantifiers, a formula that is a conjunction that is not in quantifier form cannot be either the premise or the conclusion of any of the rules, any of the instantiation or generalization rules, any of the rules governing the use of quantifiers. So you won't understand what all that means, but it's just the point is you have to be very clear on being able to distinguish quantifier statements from conjunctions. You have to be aware that this is a conjunction and thus not a quantifier statement. Okay, so this is a conjunction, right? This is a legal formula. So it's a conjunction. The left conjunct is an existential statement. You could, if you're doing a proof, simplify because you've got a conjunction, and then this is an existential statement, and you could use the instantiation rules on that. We'll get to them. This is a conjunction of an existential statement is the left conjunct. The right conjunct is a singular sentence, right? So this says AX equals X is Australian, SX equals X is a surfer, and D for Dan. So what does this say? Right, read this. You have to read it as a conjunction, right? It's telling you what? What do conjunctions tell you? They tell you that two things are true. Both of these things are true. This is true and that is true. So this says, there exists an Australian. Right, that's the first complete sentence, right? A conjunction is a conjunction of complete sentences. So the first conjunct is, there exists an X such that X is Australian, or there are Australians, and Dan is a surfer. Okay? There exists an X such that X is Australian, that's complete, and Dan is a surfer. Okay? Notice here, and that's fine, this is complete. That's one way of completing a sentence from a propositional function. This is the other way, combining a propositional function with a quantifier. So it's fine that we've mixed the two ways up, right? You'll have to get used to formulas like this, which are constructed as so. But notice here, if we have this is a problematic formula. We don't have a proper formula here because what we've got is a conjunction where the first conjunct is a complete sentence, but the second is not, right? So some terms, the scope of a quantifier is the first legal formula, first complete formula after the quantifier, same as negation, right here AX. So we say that this X is bound by this quantifier. And what does that mean? By being bound by this quantifier, it refers back to this quantifier, right? Similarly to how a pronoun refers back to the subject, right? Dan is Australian and he, pronoun, is a surfer, right? The he refers back to the subject, Dan.